Alright, in this video we're going to review what vectors are and how to add and subtract vectors. So here's a basic vector that I've drawn here. The first part of a vector is the head, that's the tip of the arrow. And the back part of it is called the tail. All vectors have two parts to them. The first is a magnitude, which is just a fancy word for how much, or the numerical value of the vector. So in this case, I'm going to give my vector a magnitude of 5 meters. So I'm talking about position. And all vectors also have a direction. That's the key that differentiates them from a scalar. So this 5 meters in position change was pointed in the northeast direction, this way. So it's not just a magnitude, but it has a direction too. And this vector could also represent anything else that's a vector, quantity. So for instance, this couldn't just be 5 meters, this could also represent a velocity of 5 meters per second. It could represent a force of 5 newtons. It could represent a momentum of 5 kilogram meters per second. So that's different from things that are scalars. For instance, time. Time is a scalar because there's no direction to time. Mass is a scalar because there's no direction of mass. Energy is also a scalar. There's no direction involved with energy. But all these other quantities over here, the vectors, they have a direction attached to them. Okay, so we're going to review real quick how to add vectors. So I'm going to throw in another vector here, let's say about the same length, but I'm going to have it point directly to the east. So I can take both of these vectors. If I want to add them, I want to put them head to tail. So I can pick these vectors up and do whatever I want with them. I can move them around wherever. But as long as I don't change how long the vector is and what direction it's pointing, I'm okay. Once you've changed it, it's not the same vector anymore. Alright, so if I'm going to add these two, I have to put the head of one on the tail of the other. So in other words, if I want to add them, I can't do this. That's tail to tail. I can't do this. That's head to head. I have to put the head of one on the tail of the other. So I'll do this. There you go. That's head to tail. So to find the resultant, which is the vector sum of these two, I have to draw a line from the start of the two vectors, which is the tail of the very first vector I put on there. Okay, over here is my start, because that's kind of like the origin. And I have to draw a line to the end, or where all the arrows originally, or where they point to. And so the end is over here. So it looks almost like a set of directions. I have a start down here, where all the vectors begin at, and then they follow here to here, and over here's the end. So I'm going to draw a vector from the start to the end. And that is my resultant. Alright, so now I'm going to take this whole thing apart and show you that it doesn't matter what order that you add them in. So we'll move the resultant down here. Now I'll take these two vectors and they'll switch places. So I'll start with the one pointing east and put it head to tail with the one pointing northeast. And now, remember, this resultant represents my vector sum of those two. So now it still fits. It doesn't matter what order I add the two vectors in. This resultant is always going to be the vector sum of the two. So if you had 3 vectors, this would work with 3 vectors too. Doesn't matter what order you go in, the vector sum is always the same. So now we'll go through subtraction of two vectors, which is basically the same thing as addition. It's just a little bit different. You have to make one little change. So normally when we add vectors, we can say that A plus B is equal to B plus A. You know, we can add them in any order. That's just like what I showed you before. I can take A and put the head of A on the tail of B, or I can put B and put the head of B on the tail of A. Doesn't matter what order I add them in. It'll be the same thing. Subtraction doesn't work like that. So if I say A minus B, that's not the same as saying B minus A. Now think about that. If I have two numbers, I don't know, 5 minus 3, that's not the same thing as 3 minus 5. It works for addition, but it doesn't work for subtraction. Okay, so what we have to do, it's a real simple fix. Instead of saying a minus b, we're going to say a plus negative b. Now, that's the same thing as negative b plus a. And I'll show you real quick, all you have to do to make it negative is change the direction of the arrow. Okay, so here I've labeled our two vectors a and b. And I want to subtract b from a. So that means I have to turn b into negative b. So to do that, all I'm going to do is take it and change its direction. Now I have a, and this is now negative b, because the arrowhead used to be over here, but now it's on this side. Okay, so now I want to subtract these two, do the same thing I did before. Move them head to tail, and then I draw my resultant. And that is the resultant of a minus b.